Great welcome at the KaVo Webinar, Quality Improvement in Dental Prosthetics by Modern Functional Analysis. Our lecturer today will be Oberarzt Dr. Ulrich Wegmann from the University of Bonn. My name is Manuel von Kienlin and I'm the moderator today. So before we start, we would like to give some organizational information. This webinar runs via voice over IP, so you can see the presentation of the lecturer and hear his voice via your PC loudspeaker. During the presentation, you are welcome to ask questions via chat in the Q&A section, either at the lower right part of the screen, or you see a green bar on the top of the screen showing the name of Ulrich Wegmann, of our presenter. And if you go with your mouse, if you wipe over that, then you have a small drop-down menu. And if you go to the Q&A section, either it's already displayed on the menu or it's in another drop-down on the right side, then just press this button and then you can press in a small field your questions. You can give your questions and we can answer these. And all these questions will be collected and answered at the end of the presentation. This webinar will be recorded and can be viewed within the next days on our website, but we will send you the link. And just in case you have technical trouble, then please call our hotline. The number is displayed below, +49 73 51 56 36 72. Now, I would like to introduce our speaker for today. It's Oberarzt Dr. Ulrich Wegmann with a presentation, Quality Improvements in Dental Prosthetics by Modern Functional Analysis. A small and brief history about Dr. Wegmann. He studied dentistry at the University of Bonn in the years 1973 to 1978. Since 1978, he is working as scientific assistant at the University of Bonn. And since 1984, he's assistant medical director at the Polyclinic for Dental Prosthetics, Propedeutics and Material Science at the University of Bonn. So you have a long history at this university. And we know you already since many years as a specialist for functional analysis, for functional diagnostics. And so we are happy to have you here. And so I would like to give you now the right for presentation. Thank you very much.
Thank you very much, Emmanuel, for this kind introduction, and hello to everybody all over the world. And it's a pleasure for me that you attend this lecture here about the BIGMA system. Because we are very limited in time, I will start immediately. And yes, that's our topic for today, quality improvement in dental prosthetics. How can we do it? But first we have to think about what is our task when we do prosthetics. We have a patient with a very complex functional system, the masticatory system, because we have not only to treat the teeth, we have to treat the whole masticatory system. When we do prosthetics, we have to look to the function of this patient. And this function must be transferred to some kind of mechanical device that we can reproduce this function in our lab. Then our technician will be able to design a functional orientated tooth surface which will match the function of the patient. And it sounds very simple, but it's very difficult to do because this function is very complex. Therefore, we have to have a lot of individual information about the patient. And that's what you can see here. We have to know the individual movements, the individual function of the patient's jaw, and that we have to simulate with our articulator. And it's no difference whether this articulator is a mechanical one or nowadays a virtual articulator on our PC. Okay, that's the task. And how can we do it? And why have we to do it in a very precise way. One of our main problems today with fixed crowns and bridges is we do it with ceramics. Ceramics are very hard materials, but when we have functional overload to these crowns, we will get some chipping. Chipping means when the occlusal surface of the tooth will break and we will lose some parts of the occlusal surface. In the first time when we made ceramic crowns, we thought this chipping comes from some problems with the firing of the ceramics or by the material itself. But what we have learned is that this chipping mostly comes from functional overload. And that's what you can see here in this picture. The fracture occurs here when there's some stop in the occlusion, and from this we have this defect here. And there's another problem with ceramics. Every time when we grind on our ceramic crown to adjust the occlusal surface, we will weaken the material. And this can be up to a reduction of the load resistance for up to 50%. And of course, if there's some overload and a reduction of load resistance, we will get a fracture. But we can avoid this problem when we do perfect occlusional design. And there's another problem related to malocclusion or mal-designed occlusional surfaces. We have to adjust this occlusion in the mouth of our patient, and that takes time. Here you can see some research about the time consuming of different restorations. In group A, it was done with mechanical Facebook transfer and check bites, let's say the traditional way to do a registration. And compared to it is a time consumption for group B with electronic registration with the Arcostigma. And you see, you can reduce the time you have to use for an occlusal adjustment. And of course, time is money. Now, let me explain in short what's the difference between the traditional concept we have used for more than 150 years for mechanical registration systems and the Arcostigma system. With the traditional articulator concept, we record the patient's anatomy. For example, with the Facebook transfer and the distance between the teeth and the joints. And then we transfer this anatomy to some artificial joint or artificial jaws. That means we only transfer anatomy, anatomical distances, reference planes, and so on. And then we say, if the articulator anatomy is equivalent to the patient's anatomy, the articulator will do the same as the patient. We say it, or better to say, we hope it. But there are some limitations with mechanical devices. And therefore, we use a new concept. I call it the Arcostigma concept. What is the difference? The difference is quite simple. We don't analyze or record anatomical data like differences and distances or positions. We record the real individual patient's jaw movements. We want to simulate the movements, therefore we have to record the movements. From these electronical recordings, we get a lot of data about these jaw movements, and from this data, we can calculate settings for our artificial joint in our articulator. That means the articulator anatomy can be, and in fact it is, different to the patient's anatomy. And that's a very important point to have in mind when we work with the Arcostigma and the proto-articulator, for example. It's not necessary to have the same anatomical relations in our artificial articulator. We have to know the movements, we have to transfer settings for this articulator. And then it's very simple to adjust the articulator to the right values, to the right guidance for the movements. Okay, that's the most important point to know. Articulator anatomy is no longer the same as the patient's anatomy. What are the advantages of these electronical movement recordings? Okay, let's have a look into the mechanical phaseboat transfer. As I said before, we have a registration and a transfer of anatomical data, distances, positions. On the other hand, with electronical recordings, we do a registration and a transfer of physiological movements, individual physiological movements of this very specific patient. And there's another difference between phasebow and Arcostigma. With the phasebow, we usually have an average coordination of these anatomical landmarks to reference planes at our mechanical articulator. On the other hand, with electronical recording, we have individualized reproduction of the patient's movements with the help of a mechanical or virtual articulator. You see the difference. On one side, the traditional mechanical phasebow, anatomical transfer, average coordination. On the other hand, electronical recording is individualized registration of the real movements. Here you can see this Arcostigma. Digma comes from Digital Movement Analyzer. And this Arcostigma is or has two main parts. The first one are the registration bows for the upper and lower jaw, and the main unit here for the calculations and the display of the results. And of course, you can connect this main unit via USB to your PC to transfer the data online from the registration device to your computer. But it's not necessary to use or to connect it to a computer. You can use it as a standalone system without connection. Then you can store the data on the left side of this unit. Here you can insert a memory card, and all your registration data will be stored on this memory card, and you can transfer the data to your PC via memory card as well as with a USB connection. When can we use the Arcostigma? Let's say you can use it with every patient where you want to do some prosthetics. Maybe you will do fixed crowns or bridges. You can use it. You can use it for partial and full dentures. That means you can use it for every patient in the full range of prosthetic works. But additionally, we can determine the physiological or therapeutical centric relation as well as the recording of the movements. And that's very helpful not only for the therapy of our patients, but also for the diagnosis of TMG disorders. And therefore, I will show you later on the different sections of the software for therapy and for diagnosis. And additionally, you can measure the muscle activity with an accessory EMG amplifier unit, which can be connected directly to the Arcostigma, and then you have simultaneous recording of muscle activity via EMG and the according jaw movements. Okay, let's have a look to the details of the system. First, the upper bow. The upper bow looks a little bit like a traditional face bow, but it's only a holder for the sensoric system, which is attached on top of this face bow. And it's not really used as a face bow. As you can see here, this upper bow is attached to the head of the patient only with these ear pads behind the ears and with a glabellar support. And therefore, you have not to adjust it to any reference plane or reference point. This is not really an earpiece. It's only for location of the posterior part of the bow, somewhat in relation to the joints. It's not a real adjustment. Fixed, the bow is only fixed by these pads and the glabellar support, and therefore you can mount it very easy and very fast. This bow can be stabilized with a rubber band behind the head of the patient, and then it's very stable, fixed to the head. Then, next one is the lower bow. The lower bow is fixed to the lower teeth, and I prefer to do it with a so-called para-occlusal clutch. As you can see here, will be this clutch located on the side of the teeth, not on the top, not on the functional surface. Why do I prefer this? I want to do the registration of the movement under the guidance of the teeth. The teeth surface has functional as a functional design, and that's what is what I want to transfer to the articulator. Therefore, sometimes or mostly, I want to do the registration under the guidance of the teeth, and for this, the upper part of the teeth must be uncovered. Therefore, I use this para-occlusal clutch that there is no contact when the patient bites. There is no contact between this registration device and the upper teeth. The lower bow is very light-weighted with 36 grams, which is equivalent to 1.3 ounce. If you want to have more information of the different designs of para-occlusal clutches, you can find more information on my website here under cmdkurse.de tutorials. How does it work? It's very simple. It works with an ultrasonic measurement system. Ultrasonic measurement system you can find at your car. for parking systems or parking assistance systems. And it's the same way they work. Here we have 4 ultrasonic transmitters at the lower bow in these 4 different positions. In the upper bow, we will find 8 microphones located here. On the left side 4 times and on the right side the other 4. And then from the ultrasonic transmitters there will be sent very short ultrasonic bursts. And from these bursts we can measure the traveling time from the transmitter to the microphone. That means from every transmitter we can get 4 different distances. From the traveling time we can calculate the distance. That means 4 distance here, 4 here, and 8 on the other side. That makes 16 different distances to get an information about the position of the lower bow in relation to the upper one. And these measurements will be done 50 times per second, and therefore we can follow these movements in a very precise way. All this data will be stored first on the Digma and then transferred to the computer via USB. It is online, via memory card, and you have some time difference, of course. If your computer is connected with a monitor in front of your patient can follow these measurements and sees online the real movements on the screen. But that's something I will show you later on. To store the data on the PC, we need some specialized software, a database system. And this comes with the Digma, and it's called KaVo Integrated Desktop, or in short, KID. Here you can see the KID just started, and now I switch over to the software itself. Hopefully it will work. Okay. Here you can see the software just started, and from the main screen of the software you can see here that it's very easy to get updates online for your KID and for your Digma. You only have to click here and then you can download and install the updates online to your system. At first, we go to the section Patient. You can select some patient which you have done a registration with some time before. Here you can see some of my patients. Or, of course, you can select new, and you can add a new patient here with his last name, first name, and other information. But let's go back into Select. Here you can see the name of the patient and the last data entry we have done, and what kinds of data are already stored for this patient. Let's have a look to this patient. I select this patient, and here you can see I've already done some different registrations with her. Her name was Eva Adam, a very strange name, but a real name indeed. Okay, I will explain it later on a little bit more, what we can see with these stored data and what we can do with it. Okay, let's go back to the presentation. And the next screen. Short explanation of the main unit. You can use it as a standalone system with every treatment chair in your practice, or you can attach it to one specific treatment chair. You can integrate it in your assistant element of your treatment chair. Integrated in this main unit, you will find a touch screen for the program. When you have started the program from the PC, there's no need any longer to have a keyboard or mouse. You do all what you want to select with the touch screen or with these membrane buttons, and it's a very smooth and clean surface, and of course it's disinfectant resistant for your hygiene. Okay, let's have a look to the main menu, and this explains in a very easy way what we can do with our Digma. First of all, we can do an articulator programming. That means we can collect all the data from the individual patient's movements to set up the articulator in the proper way. This is really an improved way compared to the Facebook transfer. But additionally, of course, we can do the Centric Record. But you are used to different kinds of systems, how to position the lower jaw in the right centric position. And therefore, you can find here 4 different buttons for different kinds of centric records. You can prefer the guided centric with a Lauritsen grip, for example, or the adduction field, or the Gothic arch tracing, especially for full dentures. And there's a new one, it's called lower jaw positioning, and that's what I prefer to have for the centric position when I treat functional diseases. This upper row here is for therapeutical use. Additionally, you can find this lower row here for function analysis, for diagnosis. And for this we have motion analysis and the position analysis. A combination of both is the so-called EAEF system from Professor Wegmann. It's a combination of motion analysis and position analysis. And when you use the EMG amplifier unit, you can use it for biofeedback or for measurement of the muscle activity while you do the centric records. But there's one difference more compared to the traditional Facebook. With the Facebook system, we refer to the individual hinge axis on arbitrary hinge axis. That's our reference points for the location of the Facebook, the mechanical Facebook. But with the ProTAR system and in combination to the Digma, there's no longer need for these reference axes because we have 2 different, not really new reference axes. The first one is a kinematic axis. It's an individual located reference axis, but this one comes from different physiological movements and is a functionally calculated axis point. We use it for diagnosis purposes, and I really cannot explain it because we are very limited with our time. But what you will use mostly in your lab will be the KaVo transfer system, KTS. And this reference is used for the therapy. The difference is, if you use the ProTAR articulator system, there is no longer any Facebook transfer required, and you have to choose for therapy the transfer system or for diagnosis the kinematic axis. Of course, you can use non-ProTAR articulator systems, but then you have to do an additional Facebook transfer with this Facebook coming from this articulator system. And there may be some limitations depending on the Facebook system you use for this. Therefore, I recommend to combine the Arcostigma with a proto-articulator system. What is this KaVo transfer system? It's a very simple system to transfer the position of the upper model into our articulator. For this, there is no need for any face bow. The only thing we have to do is to use this bite fork, and this bite fork was set into the upper teeth of the patient with some registration material. You can see the impressions, and the only thing you have to do is to adjust this indicating mark for the incisional point to the incisional point of the upper teeth. When you have done this impression and the first measurement with the Digma system, the lower bow will be attached here, then you can transfer this bite fork to a mounting stand in the lower part of the articulator. And with this, you have always the same position of the bite fork in your articulator, and this position is known to the Digma. The distance from the registration system to the artificial joints is always the same, and that makes it very simple to do the mounting of the upper model and, of course, to do the calculating of the settings for the articulator joints. In this short video, I will show you the measurement of the articulator settings with this patient. Here you can see she has to do some protrusive movement. Here, this was second protrusive movement. We do all these movements 3 times to build an average over these 3 measurements in every direction. This was the third protrusive movement. Then she has to do left lateral protrusive movement, also for 3 times. And when this is done, we go to the right side, and she has to do 3 times the right lateral movement. This is real time, and that means you can do all these measurements within less than 2 minutes. On the Digma screen, you can see online the registration of these movements for the right condyle here, for the left condyle here, and for the incisional point. When all these 9 measurements were done, you can get the calculating for the lab, and here you can see when you do the registration and your Digma is connected via USB to the PC, your patient can follow the measurements in real time. Whenever she makes a movement, she can see it in this animated skull. And of course, when the registration is done, you will get the printout for your lab. This video can be downloaded also from this website. Okay, where can we integrate this Digma registration into our workflow? It's the same as we have done before. We do a preparation of the teeth, we do an impression, and then when we have done the Facebook transfers, the check bites for protrusive, lateral protrusive positions, the check bite for centric relation, we only do the articulator programming with the Digma and the Centric Record with the Digma. Next step in our lab is upper model mounting. Traditionally, we have done it with a face bow. Now we only have to do it with a transfer stand with a KTS. The mounting of the lower model is the same as before with our Centric Record, but then it's very simple to adjust the articulator to the right settings because we have only to use the calculated values and not we have not to handle some check bytes to adjust in the articulator. And here you can see this an Articulator report which goes to the lab. Here you can see the settings, the values for adjusting the right condyle and the left condyle and the incisal point. But additionally to these values, you will find here these curvatures indicating the protrusive movement of the right condyle, the Bennett movement with the Bennett angulation, retrusive paths here for lateral movement and so on. That's for the right joint, for the left joint, and additional information about incisal guidance, canine guidance for lateral protrusive movement, and the Gothic arch tracing. All of these informations come from only these 9 recordings you have seen just before. And to make it very simple, you can transfer these data to your articulator, to the Prota articulator, and you can set it to the right values in a very easy, simple way. Let's have a short look to the Centric Record. As an example, I will show you the workflow for the guided Centric. It's the same as what you have done before. We want to have a Centric Record. At the Digma, you start by pressing this button here, and then you have to follow the instructions on the screen. So first measurement is not to measure the position. The first measurement is done as a protrusive movement. Why? We want to have the starting point of all our different movements, for the patient's movements. And for this, of course, we need some physiological movement. In this case, the protrusive movement. Therefore, we have to record the protrusive movement. In this video, you can see, first of all, we have to do a position measurement of the upper teeth in relation to the upper bow, and then we change over into the lower jaw. We can set the lower bow to the paraocclusal clutch. The patient does a protrusive movement. In the background, you can see the recording on the screen. Then we adjust the lower jaw in the right centric position, as we have done before all the time. This position will be fixed electronically. When we have done it, we add some registration material into the teeth. And then we guide the patient back in the same position as before until the material is set. That means we can start the measurement again. We have the fixed position from the first time we did in the Centric Record, and now we bring back the patient in the same position. You can see a red cross, and this red cross must match the green ring here, and we hold the patient in this position until the registration material has set. We can remove it and send this registration, this Centric Record into our lab. Why should you choose the Digma system and not another electronic registration system? Here you can compare different brands of electronic registration systems. And you can see the Arcostigma is the only one which refers to functional measurements and not to anatomical measurements. This is the difference between the Arcostigma and all these other electronic registration systems. And the transfer of the upper model position into the articulator is done without a face bow, as with the other registration systems. You only have to use this mounting stand, and this makes it very simple to transfer this position. Some short explanations about data analysis and transfer. That's what you have seen in the KIT software. I have done the recording of different registrations, and all of these registrations can be replayed, or can do a print out for the lab. And of course, I can do a data export via data file for the lab, that if the lab has the same software as me, and they can have the same recording or the same analysis of the recordings. And of course, I can send this data file to an expert to discuss this case with him to get some hints what to do in this case. Next step is that we can export this data as an ASCII file for the CAD/CAM machine to individualize the CAD/CAM design with functional movements. And we can use this ASCII data file for research or scientific use. And of course, we can import data from other measurements done by another dentist that we can discuss it. As a short example for movement analysis, I only want to show you this registration. This was done with a patient with functional disorders. You can see these different kinds of movements, and if you have a little bit experience, you can explain, or you can see what really is wrong in this left joint. The right joint looks quite good, but in the left joint we have some clicking and so on. And we can compare different measurements and a lot more. Here you can see another case with a very strong limitation in the left joint coming from an anterior disc dislocation without any repositioning. And from this you can see it's very helpful for diagnosis purposes. Okay. And another advantage of this system, you can use it for educational purpose. Here I do a demonstration of the patient's movements live in our lecture room, and the audience can follow all these movements, and you can discuss it later on. You can explain how the function of the patient movements are, and so on. And of course, you can show all these records live in the lecture room, and you can transfer this data to the virtual articulator. I will explain in short now. This is a very big advantage we have now with the Arcostigma. We can transfer these individual data, these individual movements, to a virtual articulator and do some analysis of these movements. And of course, we can use these movements to design our prosthetic work in a very easy way in our CAD/CAM system. And this can change our workflow from a more classical workflow with mechanical phasebow transfer and so on to a fully digital workflow. Registration done electronically. Unfortunately, we have to do the preparation up to now by hand, not electronically. But then we send this data, and the data coming from a scanner of the occlusional surface or the prepared teeth into our CAD/CAM system, and then we can manufacture our prosthetics. Here our virtual articulator. It's a new digital dental world, as we can call it now. Here you can see the movement, the real movement of the patient is transferred to a virtual articulator, and you can follow all these movements, and you can use these movements or these information for the design, but not only for the design, but also first, of course, for diagnosis. Here you can see the grinding and the facets here on the canine and the premolars as a sign for functional disturbance. And then you can do your design of crowns or bridges or partial dentures, which you want to manufacture by CAD/CAM systems. And you can test the occlusal surface if it's according to the individual movements of the patient or not. And I think that's a very big improvement compared to other systems where you can do only a static occlusion. Here you can do a very individualized dynamic occlusion, which fits the movements of the patient, the real movements of the patient. And another example, you can do dynamic occlusion analysis. That means you can use this system also for better adjustment of the natural teeth. When you do some prosthetics on this side, you can check, is there any disturbance on the other side, on the natural teeth, because here you can see the distances between the upper and the lower jaw as a color-coded spots here, and then you can decide, okay, here's some disturbance, there I have to adjust the natural teeth. That's also very helpful. And of course, we can show these different movements, why we have to design this curvature here in the palatinal surface of the incisors. That's very helpful for instruction of your dental technician or for the instruction of students, what kind of guidance we need in different parts of the teeth. It's very instructional for all these people. Okay, let's have a short summary. What can we do? We can do a functional optimizing of the stomatognotic system. And from this, we have a protection of periodont tooth surfaces, the muscles, and the TMGs to avoid overload to one of these parts of the masticatory system. As I said before, we can reduce the time for intraoral equilibration of our new prosthetics. In this research, they found out that the reduction is 22 up to 34% of the time we need without these electronic registration systems. And when doing diagnosis, we will get a better understanding of the function of stomatognotic system and the TMG function. And from this, we enhance the diagnostics for TMG disorders. And I think the most important advantage is that this electronic system, electronic registration system, is less time consuming compared to traditional mechanical registration methods. Okay, that was only a very short overview over the Arcostigma system. If you need some more technical information or references about the Arcostigma or the Proton Articulator system, please send an email to Hans-Walter Lang. He's responsible for design and product management at KaVo, and he will give you very good information about the system itself. And if you have some more questions about clinical or scientific problems or questions, or if you want to have courses and lectures about the Stigma system or the Proto system, please contact me via email under this address, wegmann@uni-bonn.de. And here you can ask also for courses or tutorial material on my website, or if you want to have some lectures or courses at your institution or for your institution, please contact me via email. Thank you for your audience, and it was really a pleasure to have you online here, and I hope I could give you some helpful information, and maybe we will see in a course later on. Thank you and goodbye. And now I give back, not goodbye, not goodbye for the lecture, but now you have the chance to ask me via chat. And for this, I can give back to Emanuel from Kinematic.
So thank you very much, Dr. Wegmann, for holding this excellent lecture. And yeah, again, I would like, especially because I saw that many people joined now after my introduction, so I would like to encourage you now to ask questions, any kind of questions. You can ask the questions by wiping over the green bar on the top of your screen. And there you find Q&A with a question mark, and there you just send the questions to all panelists. That's a standard setting. And now the first questions came already in during the lecture. So the first question I would like to ask Dr. Wegmann is, how do you position the patient for the registration procedure? I tend to use the position in which the patient sits upright. However, Professor Buhmann recommends that he does his recordings while the patient is almost laying in horizontal position. Do you have any comment on that?
Okay. Question is, which position to do the registration? I always prefer the patient in a most upright sitting position. Why? That's let's say a physiological position when you are awake. And then when you are awake, you will use your teeth for chewing and for speaking and so on. That means it's the most, in my opinion, the most physiological position to adjust the centric relation. Of course, some other people do it with the patient laying in the treatment chair. It's like a little bit like sleeping in a bed. But I think more important is an upright position, and that's what I've learned from very experienced physiotherapists, is that this position is the most physiological for positioning not only the TMG, but also for positioning the spine and the shoulder and so on. And from this, I think it's always a good idea to have the patient in the most upright position. Unfortunately, our treatment chairs cannot give us these upright position exactly. Therefore, you can change over to another chair where the patient is sitting in a very relaxed position, and then you can do this registration in every chair you want to use, even in a wheelchair.
Thank you very much for answering this question. Next question, how can we be sure about the centric relation measurement is correct? Only manually?
Oh, that's a very important question, because when we have done the centric relation up to now, we could do it only 2 or 3 or 4 times and then compare these different check bites in our articulator. That means we have to do 3 or 4 check bites at our patient, then go to the lab, do the mounting, and in the articulator we could compare these different positions. And mostly we found out that these positions are not the same. That means we had to decide which one could be the best. It's just a choice to find the right one. Or we had to go back to the patient. And that's different with the Arcostigma. Here, as I have shown to you, we do first the protrusive movement. From this, we can get the starting point of the movement. And I think that's the physiological position of the centric position. Then the next step is to fix these positions, for example, with hand guidance, first electronically. And then, when we have done this, then we add the registration material. And under control of the measurement with the Digma system, we can position the patient in the same position as before. That means we can control this position online on the screen. We always have the actual position of the condyles and the incisor point at this moment, and from this I can be very sure that I found the same centric position a second or third time, and therefore I have only to do one, let's say, physical registrate, one centric record, and I can be sure that's the right one because I've checked it electronically. Thank you. Next question, please.
Oh, we have a lot of more questions. Next question is, hi, I currently own Arcostigma 2. Occasionally, after articulator programming, the individual value for one of the joints, the Bennett angles, is just showing a dash, and on the other side, I get a value which is normal. Have you ever encountered this?
Oh yes, that's a very common problem. And it doesn't mean that the Digma couldn't do the right measurement. It's just that this Bennett movement is a straight protrusive, or in some cases, also a straightforward lateral movement. It's a physiological movement. We always think that this Bennett movement is a curvature guiding the condyle forward inward. But that's not the truth. With some patients, we really find a part that is guided outward. And from this, we have the value 0 or a negative value for the Bennett angulation. But that's nothing, with most of our articulators, we cannot adjust to 0 or negative Bennett angulation, and therefore the Digma shows only a dash. It's not a limitation, it's only that some patients have this kind of movement, and we cannot adjust our articulator in a proper way to these 0 or negative values. That's all. It's physiological.
Thank you very much for answering this question. So the next question is, when is the virtual articulator and CAD/CAM integration possible? Is it being launched with Arctica? This is a question that I can answer already. It will be possible by end of this year. So it will be not together with the launch of Arctica, but soon after the launch, this will be possible. So, next question. How do you find, is it a really advanced way of working in the clinic, or do you find it should be standard way of working?
Oh, for me, it's a standard way. I'm working now for more than 7 years, 8 years with the Digma system, starting with the Digma 1 and for the last years with the Digma 2, or what you have now seen is the Arcostigma. And I use it, let's say, at every day with nearly every patient. I'm specialized on prosthetics, especially in combination with implants. And for me, it's a natural way of working to use the Digma for first of all for diagnosis. And then when I do the real treatment with implants, with prosthetics, I need it for every patient to adjust the articulator and to design the occlusion in a more perfect way than before. And for me, it's a real advantage to use this Stigma system. Mechanical faceplate transfer I've done 8 years ago, so for the last time. And therefore, I'm used to the Stigma system to do it in every case. I hope this will answer your question.
Thank you very much for answering this question. Next question is, why do we need a para-occlusal clutch to fix the sensor?
We do not really need it, but it makes it better to have a para-occlusal clutch, and no clutch or attachment which covers the surface of the lower teeth. As I said before, I wanted to do a registration of the physiological movements guided by the two surfaces, and therefore the two surfaces of the upper and lower jaw must be in contact without any disturbance of the attachments. And that's not only for diagnosis, it's the same in therapy, and therefore I always use these para-occlusal clutches. You have seen this picture of a para-occlusal clutch for a patient with full dentition. But of course, you can adapt this para-occlusal clutches to every situation, up from full dentition to cases with only some remaining teeth, with implants, for partial dentures, and of course also for full dentures. And some clinical examples you can find on my website in this small tutorial. Okay, any more questions?
Is it possible to locate the centric axis without manipulations?
Oh, that's a very difficult question, because there's a lot of research about centric position. And if you're doing some kind of manipulation of the lower jaw, for example, with a Lauritsen grip or Dawson grip or something like this, you can manipulate the condyles in, let's say, nearly every physiological or unphysiological position. Therefore, I prefer to do no manipulation of the lower jaw position by my hand or by me. And I think the patient has to stabilize his lower jaw in the most physiological position by himself. And for this, I use very, very often the needle pin tracing. That means a writing plate in the lower jaw and a writing pin in the upper one. And from this, I have a very small gap between the upper and lower teeth. And then the patient has 3 points to stabilize his lower jaw in the most physiological load position for the joints. And these 3 positions are both joints and the needle pin tracing point. And from this, I believe that with this needle pin tracing, I will get the most physiological position the patient can have in this moment. What we always have to have in mind is that this centric position is, let's say, on a daily basis. We have a physiological position for today with this patient. When you do a new registration, let's say in 2 or 3 or 5 years, you will find another physiological centric position. And therefore, that's my experience on more than 30 years of dental work. Now, we have to adjust our prosthetics every 4, 5, 6 years to a new centric position. That was done on a natural way in former times with the abrasion of the teeth and abrasion of our old filling materials. But with high precious alloys and ceramics, the occlusion is very stable. There's no longer any abrasion, and therefore we have to do the adjustment over the lifetime of the prosthetics in the patient. But that's another problem. It's not really coming from the digma or from the positioning in the centric position. It's only an experience I have made over the last 30 years, which I'm working with prosthetics. Next question, please.
Oh yeah, we still have some questions. So one question is, can you mark the exact hinge axis and transfer it to the articulator?
Of course, I can do it. But why? First part of the answer, I can do it with the digma because I can select as a reference axis system also the individual hinge axis, and I can locate this individual hinge axis with the digma system, and I can mark this electronically calculated position on the skin of the patient. I cannot show it to you now because it would take a little bit longer time to explain, but you can do it. You do a rotational movement of the lower jaw as you have done with mechanical axiography. You locate this individual located hinge axis, you mark it on the skin, and you can transfer this position with a traditional face bow. You can use the digma system, or the upper bow of the digma system, as a traditional face bow. It is a traditional face bow, only added some sensoric system to it. And therefore, you can use it in both ways. Mechanically, traditional face bow transfer to individual located hinge axis, and of course, you can refer to average points, the average hinge axis points as well, and you can transfer to an articulator. Of course, you can do it, but you don't need it because you can transfer the position with a KaVo transfer system, with a mounting stand, and with the calculated values. There is no longer need for this kind of face bow transfer, but if you want. And if you don't use the Protar articulator system, you have to do it. You have to use the face bow coming with your specific articulator system, and you have to locate the hinge X points, and you have to transfer it with this face bow to your articulator system. Of course, you can do it, but it's more convenient to use the combination of digma and Protar articulator. I hope it was a little bit clear, but I can explain it in maybe in another web session later on in the next month. I hope so. Next question, please.
Okay, we hope so too. Next question is, Dr. Wegmann, when mounting the upper face bow, do you stick to any preference plane, such as the Frankfurt plane, or if you do not know, if you do not know how do you mount it? I ask this because I myself have mounted so far according to Frankfurt plane.
Okay, with a mechanical face bow transfer, we always refer to one of these reference planes like Frankfurt horizontal plane or Kemper plane. For this, you have to know to which of these reference planes your articulator is constructed, to say it in the simple way. Most of the articulator systems refer to the Frankfurt horizontal plane. The Protar articulator refers to the Kemper plane. Okay, that's traditional way to work. And with this, of course, you have to adapt the Facebook, or you have to refer to these reference planes with your Facebook. When you use the Digma system, and you use it for therapy with the KTS, with the KaVo transfer system and the mounting stand, you haven't to adjust the upper bow in any way to any reference plane. It should only be fixed at the head of the patient. And therefore, for the fixing, we use only these ear pads behind the ear. There's only a rough location of the ear pads behind the ears. No adjustment to any anatomical landmarks. And we fix it with a glabellar support. Only fixed to the head, and it must be in a stable position during your measurements. That's all. No reference plane, no anatomical landmarks, nothing else. Just fix it to the head, and with the first measurement, with a bite fork, you give the relation between the upper teeth and the upper bow, and with the next measurements, you refer from the lower teeth to the upper bow, and from these information, Digma can calculate the movements between upper and lower teeth. Therefore, no adjustment at all, and that makes it very simple and fast to fix a face bow, not the face bow, the mounting bow of the Digma to the head of the patient. You see, it makes it more simple.
Thank you very much for this answer. Two questions. One question I can answer myself. Is the kit software released for Windows 7 or only available for Windows XP? And of course, it is available for Windows 7. And now, the last question is, how do you handle an upper deviated or canted occlusal plane?
Okay, most of our patients have a more or less deviated occlusal plane. It's not really a problem because you always refer to the occlusal plane as an horizontal plane in your articulator. If you want to adjust the occlusal plane to the real horizontal plane of the patient, you can set the bite fork in this horizontal position. It's a very specific case, and you can do it for patients with a very shifted or deviated occlusal plane. But with most of our patients, you only set the bite fork in contact to the upper teeth, and then you transfer the occlusal plane of this patient to your articulator. Of course, it's shifted a little bit and tilted, but that makes no problem because the values are calculated to this position for your articulator. I hope I could answer your question.
So thank you very much, and thank you very much also to the auditory for asking all the questions and for these positive remarks that came in between the questions. I will give them, of course, to our lecturer. And at the end, I would like to say thank you very much for your participation, and some information. As soon as the recording of this webinar is available, then we will put it on our website so you have the chance to see it again. We will contact you within the next days and we'll be happy to get some feedback regarding the webinar, especially the webinar quality, and some feedback regarding functional analysis. And again, if you have any questions regarding functional analysis, then our specialist, Mr. Hans-Walter Lang, he's really looking forward to receiving your email questions. Here you have his email again, hanswalter.lang@kavo.com. I repeat it, hans-walter.lang@kavo.com. So thank you very much for your participation. Thank you very much, Dr. Wegmann, for holding this lecture, and have a nice day. Bye-bye.